Okay, so now we move on to chapter 6, which is a completely different chapter where we are going to be solving equations. And the way we decided to start this off was to remind you of chapter 2 and chapter 3 questions. And that's all day one is going to be how to answer those questions when you're trying to find an angle measure um, from a given set of ratios, and you'll see how those equations look at. So in my class, I showed them this unit circle, specifically with all these colors. I'm sure all teachers have shown this as well. And it's probably time just to review these things real quick, as far as what we were supposed to figure out from that. And the main thing that I didn't let my students use this at all, but I did have it on my calendar just to get used to, the different angle measures and the radian measures. And what we should have figured out is all 30s, which are in red, end up being sum over 6, whether it be pi over 6 or the 30 in quadrant 4, which is 330, that's 11 pi over 6. We can say it, I don't have to rewrite that. Um, those kind of things. And then all 45s, which are in blue here, end up being some sort of over 4. And those over 4s are 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And some quick things that I did with my students is, if we want to know where an over 4 is, 180 is equal to pi, which is equal to 4 pi over 4. So the quick way of getting those figured out was jump backwards, and that's 3 pi over 4, which lands you in quadrant 2, or jump forwards 1 pi over 4 and 5 pi over 4 is in quadrant 3. For, quadrant 4, 2 pi, which is a full rotation, is equal to 8 pi over 4. Jump backwards, whoa, we didn't go far enough there. And that's 7 pi over 4. So these were things that we need to exercise, again, get ready for in this chapter, because they're all back in play 100% ready to go here. And then, of course, 60-degree angles, reference angles we're talking about, are some sort of over 3. So we could play that game again here. Well, now I want to compare this to 3 pi over 3, because that's pi. Jump backwards, 2 pi over 3. Jump forwards, that's 4 pi over 3. Just 1 pi over 3 forward, which is equivalent to 60 degrees as a measure. And then for 2 pi, that's 6 pi over 3. Jumping backwards, that's 5 pi over 3. So that was the purpose of the unit circle, at least in my class, getting used to and knowing where these angles land, and what quadrants, basically. And then, of course, the all students take calculus tells you who's positive in each quadrant. So this S means sine of an angle measure that is in quadrant 2 will give you a positive ratio. We have to reverse that today because we're from ratios finding angle measures. Tangent of an angle measure in quadrant 3 will give you a positive ratio. And then cosine of a quadrant 4 angle measure will give you a positive ratio. That means its brother or sister also would be positive, so cosine and secant, but what it really means is all the rest are negative. So in quadrant 4, sine and cosecant, tangent and cotangent of an angle measure would be a negative ratio. So I had that at the bottom, my little thing, my little cheat sheet. Of course, circics or ticks, which some that are severely or sorely behind will forget that. Blah, blah, blah. But, just to make sure we have all those things down. Remember, all students take calculus. Okay. So those that know what's going on and are doing quite well and so on and so forth, you'll see that this is already something we should know. This is a quadrant. This is actually, I'm sorry, a chapter 2 question. You've already been asked this. This has already been quizzed upon. But we figured in this e-learning we got to remind you, and students probably didn't do too great on this anyway. So that's why we're going to review it. So I'm going to fly through this. I'm going to press pause for a second, take a breath. Okay, so I've broken this down into 3 types of questions. Solving from 0 to 360, row, degrees, gotta have that mark there. Missed that. Well, that's actually the generating CUDA, that's their problem. Anyway, uh, um, and then 0 to 2 pi, which means radians. That's where we got to get that unit circle and know, what's going on with that there. And then reminding you how to find all solutions through an expression. So just so you know, and I'm going to do that both in degrees. I think did I just do degrees? Oh no, all solutions in radians as well. Okay, so all solutions. So the first ones are 0 to 360, which just means within the 4 quadrants, what would the angle measures be that satisfy this equation? By the way, it would be smart to take this root 3 over 3 and make it 1 over root 3. That's what that is, unrationalized. And from doing your chapter 2 and chapter 3 stuff, we should recall that. And then what I have always done is kicks or ticks. This is x over y, because tangent is ticks and cotangent is the reciprocal brother or sister of that. And then this is what I did in my class eventually. This is the opposite side, y is. You know, when I go back up to the unit circle, you have certain ways of accessing the correct angle measure, whatever it may be. What I made people do in my classes understand, like when I have this angle measure right here, what did we have? Well, I'm just going to deal with this right here. Say we have this, and this was a 30, 60, 90 right here. 30. In my class, we stuck with 30, opposite 30 is 1, opposite 60 is root 3, opposite 90, 2. It was the y coordinate. What was opposite, or what's the y coordinate of the triangle? And the y is always the opposite side, which always correlates to the reference angle. So in my class, we were done. We had figured this out. Okay, y is root 3. I know this is the standard 30, 60, 90, where r is equal to 2 if I did the Pythagorean theorem. What is opposite root 3? It's 60 degrees. Okay, because opposite 1 is 30 and the hypotenuse is 2. So this is a 60-degree angle measure, but hold the phone. It's a positive. So where is cotangent positive? Well, of course it's positive in quadrant 1. Not here. Is this cotangent, this C? No, this is cosine. Tangent positive in quadrant 3 as well. So therefore, so is cotangent. So what I need is the 60-degree angle measures in 1 and in 3. And of course, one of the answers is 60. The other answer is the 60-degree in quadrant 3, which is this measure right here, which we need to name from here all the way from the initial side, which is always the positive x-axis, if you remember that from quadrants chapters 2 and 3. So anyway, this is 180 right here. 180 plus 60 is 240. There's your two angle measures that satisfy this situation between 0 and 360. Alrighty, we're going to speed this up because you always have a chance to relook at the video, even though we are going to be putting this in the edpuzzle. I think you can do edpuzzles over and over again too, just to practice, and we'll set it up that way too. Alrighty then, cosine of theta equals -1/2. By the way, that negative has to be on the 1 because r is always positive. X over r is what cosine is. Kixer in my class. So what does that mean the y value is? Well, you should recognize these as the classic 1 root 3, 2. This is a 30, 60, 90 right triangle. Boom. As I said in my class, we should have gotten to this. That is the opposite side. Y is always opposite the reference angle. So yet again, we have a 60-degree reference angle. Okay? And I could do that and prove that through drawing this real quick. I'm not going to do it every single time. By the way, where's cosine negative? Well, A, S, T, C. It's not negative in quadrant 1 because nobody is. And it's not negative in quadrant 4 because that C stands for cosine. So it's these triangles. And I had people make triangles and some students got upset. Imagine. I don't have to show my work. I know everything. All right. 1 root 3 down as well. And then 2, 2. There we go again. This is the opposite side. So root 3 is the opposite side of the reference angle, which is 60. But now what we have is a 60, oops, let's go back. A 60 in 2 and 3, and I want it in degrees. So the 60 in quadrant 2 is 180 minus 60. It's not rocket science here, folks. You don't have to make that as a memorization. This is 180, and then I got to jump back that 60-degree angle measure. So that's 120. And then in quadrant 3, you go 180, and then you go 60 more. That's simply 180 plus 60, which is 240. All right, that's all she wrote for that. Then I threw in these little suckers, little one-steppers. You know, I thought, okay, let's just exercise some algebra a little bit, because this is what eventually we're going to run into. You're going to have to do some factoring and solving trig equations just like you did with polynomials. And I thought I'd throw in one-steppers here. So I got to get tan theta. That is our variable all by itself. So how would I do that? I'd multiply both sides by 4/3. I try to teach fractions every week, like three times a week, because of these students that are fractionally challenged. All right, and trying to get them to think fractionally and make it easy. And I kind of have to write this messily. That does not say minus now. It's just a negative √3/4 times 4/3. Oh, so these 4's cancel, and now I have tan of theta. I like writing tan on the left side. Equals 4's cancel, negative √3/3. That looks familiar, except the only difference is it's now tan of theta, not cotan of theta, and it's a negative. Okay, one more time. You probably want to make this -1/√3, unrationalizing the denominator, crazy, or rationalizing the numerator. That's what a calculus student would say. This is y over x. Here you go again. I know I have a 30, 60, 90 right triangle. R would have to equal 2 through the Pythagorean theorem. So y being the opposite side, the reference angle is a 30. And then all students take calculus. All students take, yeah, my pen's doing some crazy stuff, trying to drive me nuts. We're not in 1 and 3 because tangent's positive in 1 and 3. So we are in 2 and 4. Since y is 1, the opposite side, that makes it a 30-degree reference angle, because the side 1 is opposite 30 degrees, 3 is opposite 60 degrees, 2 is opposite 90 degrees, and the reference angle, I'm going to keep reiterating this until I get everyone on the bus, the math bus where we all sing songs and we're happy that we know what the heck we're doing. The y is always the opposite side of the reference angle. The reference angle is always connected to the origin. It's always right here. Okay, so that's why we did that in our class. Anywho, it's a 30 in 2 and in 3. So what are the 30s in 2? That's 180 minus 30, which is 150, because you jump backwards 30 this way, name it that way. And then in 3, you jump forwards. Wrong, it's in quadrant 4. So you go 360, but then jump back 30, because that's what the angle is. The reference angle is right in there. So that's 330. All right. Already moving a little bit too far into the video. We're running short on time. So I'm just going to go ahead and do this one offline. If you want to try it, press pause. Go ahead. I'm not even going to put this in the edpuzzle, but I'm going to go ahead and solve this one. And then if you want to stop the video and do it yourself and then check yourself before you wreck yourself, go right ahead. Okay, there you go. This is a special case. Subtracted 3 from both sides, which is actually the same as 6/2 to get a common denominator over here. And then multiply both sides by 2. You get sine of theta equals 1. There's only one case where that happens, and that's at 90 degrees. All right, moving on to the radian section. And I doubt I'm going to be able to probably get through 2 of these. And then hopefully you just understand how to, ooh, that's a tough one. I don't think in the homework I made those as difficult. But how you do these couple steppers, just use your fraction ideas and so on and so forth. Okay? All right, well, right away we get a special one here, but the only difference with this one is 0 to 2 pi. Well, now we're answering in radians. And really it just takes one more thing to do compared to the last question. So right away, this is x and this is r, because kicks are, all right? Well, what does that mean y is? Well, 1 squared equals 1 squared. That's the Pythagorean theorem thinking, so y has to be 0. 1 squared plus 0 squared equals 1 squared. We should have an idea of the Pythagorean theorem. as far as completing. These are all kind of right triangles in the coordinate plane. Where do you have 1 as a x value and 0 as a y? And it's right there. That's 1 comma 0. So this is, oh no, 0 degrees. Wrong, it's 0 radians. But in this case, you wouldn't. There's no difference between the two. Just don't put a degree mark on that 0. So 0 radians is the answer for that one. Not very special, okay? And that's one of those special cases, though, so I guess it is kind of special. Again, when you have these, hopefully you recognize this. All right, yeah, I remember those ratios from chapter 2 and 3. And I want to unrationalize this. This is where this comes from. 2 over root 3, you'd multiply both top and bottom by root 3 to get 2 root 3 over 3. But you want to unrationalize it. And then remember, cosecant is the flip of sine, and sine is y over r. Sir. So this is r over y. It should be over. As I told you already in this video, y is the opposite side of the reference angle always. Just for giggles, x is also equal to 1, the classic 1 root 3, 2 ratios. But y is the opposite side of the reference angle. And that means this is a 60. The next thing is ASTC. Where is sine and cosecant positive? And the answer is 1 and 2. So I have a 60 and 1, and I have a 60 and 2. 60s in radians are over, anyone? 3s. The quadrant 1 ones are always just pi over. The quadrant 2 one, again, this is 3 pi over 3, jump backwards, and that's 2 pi over 3. So we're getting that exercise of those, remembering those radian measures and how they relate to degree measures. All right. Okay, I wanted to keep this under 20 minutes, so I'll just hold off on these. I always have like an idea of what I wanted to do, and it just takes a little bit longer. So I'm going to go to the all solutions, because it does take a little bit of time on this. And we're going to start with radians, because we just did radians, so I could talk about this one real quick. Same start. And I believe if we're, I'm not even going to get into that. I was about to talk about something that's just semantic, but this is y over r again. All right, you quicksters. And the negative has to be on the y because r is never negative. This is the reference angle. And of course, x would have to equal root 3 if you did the Pythagorean theorem, the classic 1 root 3, 2 thing. Whatever you need to do to get these figured out. This is how my class, I really wanted you to get to this part. Identify the y. It is opposite the reference angle. And 1 is always opposite 30 degrees. Then the next thing is, where is sine negative? ASTC. Shouldn't have to write it all the time. There goes my pen going crazy. All are positive in 1. This is not positive. Sine is positive in 1. This is not positive. This means we have a quadrant 3 and a quadrant 4 angle measure because sine has to be negative in 3 and 4 because tangent and cotangent are positive in 3. The others are negative. Cosine and secant are positive in quadrant 4. All the other ones are negative, including sine. And I can prove it after I do this, but now what we need is what are the 30 degrees? No, I already wrote that back. Yeah, that's going to cut into our time wasted. So what's the 30 in quadrant 3? 30s are over 6s. And then I'll show you how to write these in all solutions. What's the 30 in quadrant 3? Well, this is 6 pi over 6. That's pi. That's 180 degrees coming from here to here. Jump forward 1 pi over 6 and you get 7 pi over 6. The quadrant 4 one, this is 12 pi over. This is all 100% review. So we should all remember this and this should come back real quick. That's 11 pi over 6. Now, this is where it gets a little hairy on all solutions. How do we write this? Here's 7 pi over 6. Here's 11 pi over 6. And here's what we have to focus on with all solutions and why this one, hold on a second. Yeehaw! Because I know what wait. That was an improper lasso. Yeehaw! All right. We're going to be able to get these answers right now. Because what you want to focus on these all solutions, by the way, we did this with asymptotes and all this, is this the same distance as this? And I think everyone could understand that that is absolutely not the same distance. So how do I write all solutions that land here every single time? Well, you remember that we could go an infinite amount of circles on a unit circle. So I could draw this angle, that's 7 pi over 6, but then I also could do this angle measure, which is adding 2 pi to 7 pi over 6. Or I could do this answer, 1, 2 rotations, and then land there. That's 2 pi's added to that. Or I could go this way, which is a negative angle measure. Basically what I'm showing you is you just add that 2 pi n generator, and n is an element of integers. And we've been doing this all year long. We did it with asymptotes, and naming all asymptotes, naming, if you know what I'm talking about there. So because these cannot be connected, you basically tack on 2 pi n's on this, and that represents all radian measures that work for this particular scenario. And then this one's going to be special. It's going to be a little bit different. By the way, root 3 over 1. What's cotangent? Related to tangent, which tangents ticks, that means cotangent is x over y, the flip of that. And if you're catching on to what I'm doing here, of course r is equal to 2. This is a 30, 60, 90. We got a reference angle that's 30 degrees. All right, I think I missed the 45s because of some that I skipped, but there goes my, I gotta maybe make up one real quick here, 45 happening. So where's cotangent? Positive, because this is a positive angle measure. Here we go again, ASTC. At this point, we should be figuring out that we have a 1 and a 3. All right, now I don't want to skip over the directions. I want all solutions, but now we're going to jump back to degrees. So notice this. Here's the 30 in quadrant 1. Here's the 30 in quadrant 3. Notice that these are exactly equidistant from here to there and there to there, not like these last ones, this last question. So you're going to find when you're dealing with cotangent and tan, this happens. So if you did this and said 30 degrees, and then I hope you know that this is 210 degrees, and you just added 360n, you're not necessarily wrong, because that's how you find all the angle measures, but in a multiple choice, you will not see that answer. You will see 30 degrees plus 180 degrees n, because if I'm here at 30 degrees and I add 180, then I get to this one. Then if I add another 180, I get to this one. If I subtract the 180, I get to this one. This is the ultimate condensed correct answer that you will see in a multiple choice scenario. This happens on tangent and cotangent, okay? But really what you want to make sure is you look at the question graphically, meaning not graphing it, but look at where they're at and see how far away they are. And if it's like the last one, then you just tack on either 360 n's or 2 pi n's, depending if it's in radians or degrees.